So after the standard, what you can say, electrode potential, we studied the standard electrode potential, how to calculate. So the last class we studied about the oxidation potential, we studied about the reduction potential, we studied standard electrode potential. We also studied how to calculate the EMF of the cell. EMF of the cell is nothing but E cathode minus E anode. I said it. Got it? And standard EMF of the cell will be what? E naught cathode minus E naught anode. And I said you, what is the condition for standard EMF? The condition should be that the temperature of the electrolytic cell should be 298 Kelvin, that is room temperature, and the concentration of the electrolyte should be 1 molar, that is the solution which you will be taking, the concentration of the electrolyte, it should be 1 molar, and that is the pressure of the gas. Suppose the electrode is gaseous, and the pressure of the gas should be 1 atm. So this would be the condition. Now based upon this fact only, we will do today standard hydrogen electrode, that is SHE, or it is also called as normal hydrogen electrode, NHE. Understood? Standard hydrogen electrode or normal hydrogen electrode, we can say that SHE or NHE. Alright? Acha. Now before starting the SHE or NHE, now this is nothing but a single electrode potential. Now remember it, that single electrode potential is not possible in electrochemistry. Alright, to carry out the experiment on electrochemical reactions. Why? Because with cathode, single electrode potential means either it can be cathode or it can be anode. Alright, you know cathode and anode, they are complementary. Because if what you can say, electrolytic reaction is taking place, one has to be oxidation, other has to be reduction. Is it possible that only oxidation reaction is going to take place, only reduction reaction is going to take place? No. So hence they are complementary, both are, that is cathode and anode. So hence for that particular purpose, it is not possible that you will be getting a single electrode potential. It is not possible at all that a single electrode potential will carry out the experiment on electrochemical cell or carry out the experiment on electrolysis. I hope you got it. Alright, this question is also there, that why a single electrode potential is not possible? Because single electrode potential is not possible because that will not complete the circuit. Because cathode and anode, they are complementary. If a electrochemical reaction is taking place, if one reaction is oxidation which is taking place at the anode, then the other reaction has to be reduction which is taking place at the cathode. It has to be. So if single electrode is there, if oxidation is taking place, where the reduction is going to take place, or suppose if the reduction is taking place, where the oxidation is going to take place. So hence single electrode potential is not possible, we can say that. Clear? Okay, fine. Now next is, then what is SHE or what is NHE? How do we construct it? First let us see the construction of SHE or NHE. So for that purpose, what we need to do is that we will take a trough. Alright, we will take a trough which contains dilute HCl. Got it? I have taken here dilute HCl or dilute H2SO4, whatever you can take it. Clear? You can take it. Better is to take dilute HCl. And the concentration of the electrolyte is 1 molar. That is standard. Alright. Now here I will be taking a glass jacket. As you can see it here, I will be taking a glass jacket which is having an opening here. As you can see it here, and it's having an opening here. And here I will be taking, that is inside the glass jacket, I will be taking a glass test tube, we can say that. The test tube contains, at the bottom of the test tube, it contains some mercury present in it. The bottom of the test tube, it contains mercury. This is your mercury. The bottom of the test tube, as you can see, it contains mercury present in it. Got it? It's inbuilt, this particular thing. It is inbuilt. The glass jacket contains test tube which contains some mercury. Now, here inside that particular test tube, we are having a copper wire. This is a copper wire. A metallic wire is being present here. A copper wire, as you can see it here. A copper wire is being present. Alright. It should be a straight one, of course. Okay, fine. Now, this is being connected to a battery, we can say that. And this, through this inlet, hydrogen gas is allowed to enter into this electrolytic, into this particular solution. And the hydrogen gas which is allowed to enter, it should be at 1 atm pressure. Now, here the copper wire is there, the copper wire, we can say that. And from the bottom, listen carefully, we are having another wire, that is a platinum wire. We are having, this is a platinum wire, understood? Clear? And it is ending in a platinum block. This is a PT block, platinum block. Now this platinum block is being coated with platinized black. Alright, listen carefully. This is a block of, what you can say, this is a block of, that is nothing but platinum, which is being dipped in a HCl solution. And this platinized block, this platinum block is being coated with a platinized black. Now what is platinized black? When you heat platinum to a very high temperature, because metal, when you will be heating platinum to a very high temperature, then what happens is that, just like carbon, alright, platinum also becomes, what you can say, black powdery mass. We can say that it becomes a black powdery mass. So that particular black powdery mass is known as platinized black, it is said to be as. So what you do is that you take that platinized black and you put it over the block of platinum. You put it over the block of platinum. Why? Because you know that you will be studying this particular one in surface chemistry, or you might have studied in the lower classes somewhere, that to increase the rate of adsorption, because when I am going to pass the hydrogen gas into it, the hydrogen gas will be adsorbed, AD, not AB, AD, it is going to get adsorbed on the surface of this platinum. So if you take, what you can say, the surface of the platinum, it is being coated with platinized black, then it will, the rate of adsorption of the hydrogen gas is going to increase. The rate of adsorption of hydrogen gas is going to increase. Alright, clear what I said? We are going to pass the hydrogen gas through it. And here I have taken a platinum, a block of platinum which is coated with platinized black. Why do we need to coat it? Because to increase the rate of adsorption of hydrogen gas. Because the smaller particles, alright, it adsorbs hydrogen gas faster, more than, what you can say, a solid one. For example, I am telling you, you will be reading again in chemical kinetics this particular one. I am taking a glass of water, alright, and I am adding some sugar candy into the water. Sugar candy, misery, I am adding into the water. I am taking another glass of water. I am adding some sugar particles into the water. Same mass I am adding to it. Which will dissolve faster? Sir, you will say sugar, not sugar candy. Sugar is going to dissolve faster. Why? Because the particle size is smaller. Hence it is going to dissolve faster. Sugar candy is bigger, so it is going to dissolve at a slower rate. So here also same thing I said. I am coating platinum block with platinized black. Platinized black, what I said, it's a powder. When you will be heating platinum to a high temperature, it becomes powdery mass, just like carbon, and you are going to coat it over it. Why? Because that will increase the rate of adsorption. It will adsorb more and more of hydrogen gas on its surface. On its surface, because adsorption always takes place on the surface. It's a surface phenomena. Alright, absorption is a total phenomena. Alright, like a sponge absorbs water. It does not absorb, completely it absorbs. But what it here is that, here you can see charcoal. It absorbs the hydrogen gas. You might have studied in the low classes. Here also same thing, the platinized black, it adsorbs. Now you have understood what is adsorption. So I am going to pass the hydrogen gas, and as it is being coated with platinized black, more and more of hydrogen gas will be adsorbed on the surface. Now when this solution gets saturated with hydrogen gas, you will see bubbles are rising from it. Bubbles are rising from it. So what are these bubbles? These are nothing but hydrogen gas bubbles. Hydrogen gas bubbles, you can see. Now why this hydrogen gas bubbles rises? Because initially when I am passing the hydrogen gas into it, the hydrogen gas gets absorbed in, what you can say, this in this particular solution, in this particular platinized platinum block. It gets adsorbed, but it has also got some saturation point, isn't it? So when the solution gets saturated with hydrogen gas, then it cannot hold more of the hydrogen gas. So that hydrogen gas, it comes out in the form of bubbles. When the hydrogen gas is coming out in the form of bubbles, you stop passing hydrogen gas into it. You stop passing the hydrogen gas into it. Now this platinum is being coated, it's being saturated with hydrogen gas. This solution is being saturated with hydrogen gas. Got it? So now this particular, it acts as an electrode. This entire setup acts as an electrode. What is that? Standard hydrogen electrode. Got it now? Clear? You can see this wire. This is a copper wire which has been connected to a battery. Got it? It's been connected to a battery, this particular one. And this is a setup. It's a glass jacket. It's having a inlet through which we pass the hydrogen gas into it. We are having mercury, which acts as a good conductor of electricity, and this mercury is being, in the upper side, it is being connected to a copper wire which ends in a electric wire, and here in the lower, at the bottom, you can see it is being connected to a platinum. I think you understood the setup. Alright, clear? So the entire, you can see that it is at 1 molar concentration, it is at 1 atm, and it is being carried out at room temperature. Now what the reactions is going to take place? Now let us say as I said you, this is being connected to a battery. Let us say this is acting as cathode. Let us say it acts as a cathode, because single electrode, na, it can act as cathode or anode, both. So let us say it acts as a cathode. So in cathode, which reaction takes place? Reduction reaction takes place in cathode. But before that, you need to understand that HCl, what you find is that dissociates to give you H plus Cl minus, isn't it? We get it, HCl. Aqueous HCl, I have taken it, it dissociates to give this. Fine. So at cathode, what I said you, reduction, that means H plus E minus will give you, that is nothing but half H2. Why did I write half H2? Because H does not exist. So hence I can write the what you can say, this what you can say, that is nothing but, this is the reaction I have written it. This is a cell notation I have written it. Cell representation. So H plus slash half H2 at cathode. Got it? We got it. At H plus half H2. Now next, at anode. Suppose it acts as anode. So anode means what will happen? It will lose electron. What it is going to lose? Hydrogen gas loses electron. So half H2 minus E minus will give you what? H plus. So it loses electron. So that means at anode, what we can say, half H2 slash H plus. Now I said you that while putting this value in E cell to calculate the EMF of the cell, alright, to calculate the EMF of the cell, this has to be converted into reduction potential. Last class I said that always the oxidation potential has to be converted into reduction potential. How do we convert the oxidation potential to reduction potential? Just to change the sign. But here there is no value. If suppose value is there, I will change the sign. Here value is not there. So what will I do? I will change this one only. So what it becomes? If when it is in reduction potential, what it becomes? H plus slash half H2, isn't it? Listen carefully. What I said is that anything given in oxidation potential, you convert it into reduction potential, because to calculate the EMF of the cell, we use a formula E cathode minus E anode. So here it is standard EMF. So we will say E naught cell is equal to E naught cathode minus E naught anode. E naught cathode minus E naught anode, isn't it? So anode is here oxidation potential. As you can see, oxidation is taking place. What I said you, according to the international system, everything has to be converted into reduction potential. So how do we convert the oxidation potential to reduction potential? The value which will be given, we need to change the sign. But here is the value is given? No, value is not given. Then what we'll do? We will change the equations. The equation is going to change. Then only it will be done. See, half H2 minus E electron will give you H plus. So if I change it this way, what it will be? H plus electron will give you half H2. Reduction. So that's what I have written. H plus electron gives half H2. So that is H plus 2 half H2. Got it now? Fine. So now this is in reduction potential. This is an oxidation potential. This you can see in reduction potential. Okay? Fine. I'll put the value now here. I am rubbing it this one. You have understood this. Now I'll put the value here. So now see. I'll put the value here. This one is what I said. That is E naught cathode minus E naught anode. So what is E naught cathode? I am putting it here above. Alright. So E naught cathode, what you got it? H plus slash half H2. What is anode? You got it? Same thing you got it. H plus slash half H2. Got it? Now, what is this? Both are same. This is equal to 0. So hence, what is the value of SHE or NHE? It is nothing but 0.0. It's actually 0 volt, but it is better I am writing 0.0, because if I write 0 volt in this way, you may read it as OV, isn't it? But if I write it in this way, means it is correct. That's 0.0 volt. So what is the value of SHE? What is the value of standard hydrogen electrode? What is the electrode potential of standard hydrogen electrode? It is 0 volt. Understood how it is 0 volt? In this way we got 0 volt. So standard hydrogen electrode is taken to be as the standard electrode potential. Alright, for knowing which is cathode and which is anode for electrochemical reaction is being taken. To find it out which is the cathode and which is anode. Now I am going to do it and I am going to show you that how it is we use it to find the cathode and anode. And moreover, what is the value of standard hydrogen electrode? Its value means potential. What is the electrode potential of standard hydrogen electrode? It is how much it is? 0 volt. Got it? How it is 0 volt? I have proved it here. I have found out it here. That is at 0 volt. Thank you.